Answer is 205. Answer is 10.
Alright, that's what I just now got.
Oh, darn.
Answer is 216. Answer is 241. Last one. Answer should be 20. Pick a number from 1 to 10. Winning numbers today are 10 and 1. Today, your objectives are to plot polar coordinate points, to convert from radians to degrees, to convert from degrees to radians. Example number 1. Graphing polar coordinates in degrees. This is the set that you're going to use. Instead of x, y with rectangular coordinates, these are polar coordinates, where the graph is circular instead of square. Instead of x, y, you have r theta, and this represents a radius and an angle. And those are clearly marked off on the graph. A radius and an angle. This is a polar coordinate graph. Notice that it starts at 0 here, and it goes all the way around. Some polar coordinate graphs are sectioned off in 30-degree increments. This one is in 15-degree increments. And it goes all the way around. If it comes back around and stops right here, what is the degree measurement? 360. If you're starting from here then and you stay there, then it's 0. Every time you go around, it's 360. And the way you would plot a point on this is if I said, for example, 3 and 165. I would have to find the third ring on the graph. This is the third ring here. That's where I'm going to be at. However, I need to go to the 165 spoke, which is here. You don't have to draw the circle or trace it. You just have to put the dot on 3 165. Each ring represents 1 unit out. This is the first one, second, third, fourth, fifth, sixth, however many the graph may have. I try to keep it open enough to where you can see where the markings are at and not so many markings on there that it's bunched together and you can't read it. So if I plotted 330, this is what it would look like. I'm out 3 and I'm on the 30-degree spoke. If I plotted 5 and 210, I go out to the 5th ring and then I'm on the 210 spoke. This would be 1 and 135. This would be 2 and 285. If you can plot the points, you're doing good so far. This is example number 2. What are the coordinates of that dot? 575, yes. If you can do that, you're doing good. Let's see if you can do that. This is a practice problem, and drop off the answer. Lay it on the table. Bring me the coordinates of that point. This one goes out 1, 2, 3, 4 and is on the 210 spoke. If you have that, come and get your paper. Bonus problem number 1. Should be 5 and 150. Practice problem number 2. Solution to the practice is that it goes out 1, 2, 3, 4, so it should be 4, 3, 30. Bonus number 2. On this one, the answer should be 3, 15. Example problem number 3. Convert from degrees to radians. To go from degrees to radians, you must do the following. Multiply by pi over 180. and then reduce. Don't make this into a big decimal, even though you could, and we may later on, but not now. So that's really 30 pi over 180, but make your cancellations. 30 into itself once, into 180 6 times. So it should be pi over 6. Notice that I did not write 1 pi over 6. That is wrong. We don't write anything with a 1 beside it that's a variable or pi or any other symbol. Pi over 6 is the answer. Example number 4. Convert from degrees to radians. 75. Multiply that by pi over 180. That would be 75 pi over 180, and 15 should go into both of them. 15 into 75 5 times, and into 180 12 times. 5 pi over 12. Try practice problem number 3 and drop it off. For the practice problem, multiply by pi over 180. That's 150 pi over 180, and 30 will go into each of these. Into 150 5 times, into 180 6 times. So it's 5 pi over 6. Bonus number 3. For the bonus problem, you multiply by pi over 180. That gives you 200 pi over 180, which cancels out to 20 pi over 18. But that can be canceled out to 10 pi over 9. Practice number 4. For the practice problem, multiply by pi over 180, and that is 330 pi over 180. Cancel the zeros, 33 pi over 18, and 3 goes into both of those, into 33 11 times, and into 18 6 times. Bonus number 4. For the bonus problem, you might have to multiply by pi over 180, and that'll give you 100 pi over 180. Cancel out the zeros to get 10 pi over 18, and then cut that by 2's to get 5 pi over 9. Example number 5. This is the same polar coordinate, with the exception that it's not listed in degrees, it's listed in radians. These are still 15-degree increments here. These are the corresponding degree measurements, but now they're in radians. So in other words, I've gone all the way around the wheel and converted every degree measurement to radians. You must be able to express the coordinates of a point in terms of degrees as well as radians. So before, it was going to be like 3 and 230. Now it's going to be 1 and maybe pi over 4. So you have to understand how to do that. Example, problem number 6. What is this dot? Five and 23 pi over 12. That is right. So if you're in doubt about what the radian measurement is around a wheel, you should be able to generate this on your own. For example, if you get something on a blank grid, then you should be able to identify how far out it is from the center and what increments it's in, and then convert to radians if you have to. Practice problem number 5. This one I want the coordinates in radians, and this is the same graph as before. Remember, these are in 15-degree increments. 15-degree increments starting here at 0, and I want the degree measurement in radians. For the practice problem, this degree measurement is 180. Therefore, the one behind it should be 165. So if we convert this to radians, we multiply by pi over 180. That would be 11 pi over 12, and this one goes out 2. So it's 2 and 11 pi over 12. Bonus number 5. For the bonus problem, you know these are in 15-degree increments, therefore this is 75 degrees. If you convert that to radians, you multiply by pi over 180 and then reduce it down. 15 goes into 75 5 times and into 180 12 times. 5 pi over 12, and this is going out 1, 2, 3, 4, 5, 6. 6 and 5 pi over 12 is the bonus. Practice problem number 6. On the practice, remember this is 180, so this is 165, this is 150. 150 over 1 times pi over 180, and that's going to end up giving me 3. I wrote 3. I don't know what I'm saying here. 30 into 155 times, so I was right. There we go. Pi over 6, and of course it goes out to 1, 2, 3, 4. So it's 4, 5 pi over 6. Bonus number 6. For the bonus problem, remember this is 360, so if you count back that's 345, and this is 330, so this one would be 315. And if I multiply that by pi over 180, I'm going to have 15 going into 315 21 times, and 15 into 180 12 times. But you have to reduce that. 3 goes into both. So that would be 7 pi over 4, and it goes out to the 1 rung there. Example problem number 7. You have to convert from radians to degrees. To convert from radians to degrees, you have to multiply by 180 over pi, which conveniently cancels out the pi's, and then you're left to make some other cancellations, such as 3 into itself once, into 180 60 times. So you should end up with 120 degrees from 2 times 60. Remember to multiply by pi over 180 when converting from radians to degrees. Example number 8. To convert from radians to degrees, multiply by 180 over pi. The pi's cancel out, and I can cancel 10 with 180 to get an 18. And then 9 times 18 would be 162. Homework is next.